Hello, folks. Welcome to Rational Science, the only site on the internet that does physics for real. Yesterday, I came back from Iceland. Nice trip. I celebrated my 45th honeymoon. Long time. Never go to Iceland. It's too cold, too windy, too rainy, too expensive. Don't ever make that mistake. Okay, anyways, we're going to be doing a little bit of extinction first, and then we're going to go into the lecture that we have today, which is on whether the electron, in fact, essentially the entire atom, whether any of that belongs to geometry. In other words, do any of those qualify as geometric figures? Okay, and then I'll get into the questions and comments that people made. For the last 3 weeks, I'd say at least, I haven't been able to give my lecture. Okay, let's go with extinction. Let's start here. Fellow says he went to this site. He asked me to go to this site, to this YouTube video. I think it was a YouTube video. And the fellow there, he says the following. He goes through the whole extinction thing of what happened at the KT extinction, which is the Cretaceous Tertiary extinction, which is 65 million years ago roughly, and that's when the dinosaurs died and mammals expanded. So this fellow in the video says the following. He says, one of the statements he makes, he says, even if there were no asteroid, a lot of dinosaurs and marine life would probably be gone anyway. Well, he never explained why he thinks that is the case. In fact, when you listen to the video, this is what you see. He just goes in there and regurgitates the party line. He starts out by saying that the asteroid is the number one theory. Then there could be climate change for different reasons. Maybe volcanoes, the Deccan traps in India, and maybe there was climate change, or maybe in this case marine regression. The ocean levels dropped. So what should you conclude? Well, you should conclude that these people keep telling you the same story over and over for the last 50 years. They have no different theory. If you want to have a different theory, you have to come here. There is no other place for a different theory. What's the theory here? The theory here is that the economy collapsed. The dinosaurs' economy collapsed. And people don't always understand what that really means. It means that we are animals. We are humans, are animals, just like the dinosaurs were animals, the amphibians were animals, all these were animals. Okay? People think that we're not animals and that we're kind of different and we're going to die a different death than the animals in the past because we have something called intelligence. We have developed this extraordinary intelligence, and that saves us from all fates. I can only give you my 5 cents worth, and that 5 cents worth is that Mother Nature kills through the vitals, what I call the vitals. And the vitals are not trade, not commerce, not money. Not all animals have money, not all animals trade, not all animals engage in commerce. All animals have some things in common. They typically breathe, they typically drink water or some kind of liquid, and they typically eat something, where they sometimes get their liquids from. So that's universal. Another universal could be that they all have children. They all sleep. Okay, so we have some things in common with all the other animals in the animal kingdom. And so the question is, does Mother Nature kill through money? Well, not specifically. Not specifically. Other animals don't have money. So she goes through the vitals. Now, one vital could be, having fewer children. She stops the species from having children. And when that happens, what we call a background extinction, yeah, the species can go extinct. However, in the case of humans, we're probably not going to die through a what I call a background extinction. In other words, we're only us, we disappear, and the rest of the world continues rolling like if nothing. No, no, that ain't going to happen. When we die, everyone dies. We're going to take everyone with us, and that's known as a mass extinction. So we're going to die in a mass extinction. And for that, we need to go back to the dinosaurs and figure out how they died, how the amphibians died, how the archosaurs died, how the mammal reptiles died in the Permian, and so on. We got to go through different ages and figure out what happened to them and see if whatever killed them is going to kill us and whether we have any antidote to whatever killed them. Is intelligence, is technology, is the fact that we can foresee events, does any of that help us avoid extinction or avoid the mechanism that killed all the other animals? That's the reasoning here, okay? And so we go back and we find out that, yeah, that maybe they were killed through one of the vitals. Maybe they lacked sleep. I don't think so. I think it wasn't an issue of sleep. Could it be that maybe they ran out of air? Well, it could have happened. Maybe there was a climate change, a sudden climate change, no air, and they all died. Yeah, great. I don't think that happened either. No, I think it goes down to liquids, water, and food. Okay, so that's more likely. And what do I mean by that? Well, if the food disappears, for sure, the food that the dinosaurs ate disappears, the herbivores will disappear and then followed by the carnivores. Okay, so that's the idea here. And the same thing can happen to us. Food can disappear. And you say, well, how can that possibly be? We have trade, we produce all the food we want, we're all fat. Well, it can disappear because we only produce food for money, for profits. The day that money is no more, that we don't believe in money and in God we don't trust anymore, then that's when money is no more. We don't produce anymore because we only produce because of money, or distribute because of money. And so I think it's going to be the same mechanism. In the case of man, it's just going to be through commerce, through trade, but the mechanism is the same. We run out of food. It's food that's going to kill us, okay? And that's what killed the animals in the past. That's the theory we propose here. So, this notion that climate change does anything to us, that peak oil, that disease, some kind of disease kills us, that there's a volcano that's going to kill us, that there are asteroids and comets that are going to come and hit us, I don't think so. None of those will ever happen. Mother Nature doesn't do extinction, mass extinctions in such a way. She does it through the vitals, primarily food and water or liquids. Okay, so that's the distinction here. Okay, another fellow brings up an issue. He says, why would you think that in an age where people are getting fatter and fatter, the world will be out of food soon? Well, again, it's got to do with economics falling apart, and we produce food only because of economics, because of trade, because of commerce, because of money. Okay, for profits. That's why we produce food and distribute food. If we were to wipe out money for whatever reason, then we will all, or a great majority of mankind will die because of lack of food. But very simple, very straightforward. So that's the mechanism proposed here, because that's how the animals in the past died, according to this site. Why would you think that in an age of crypto coins and digital currencies becoming popular can provide basic income? Yeah, don't you think you are rationalizing the idea of an end to all humans to cope with the fact that the fall of the American empire is occurring right now, and you happen to be right smack in the middle of it? Yeah, maybe. It's got really nothing to do specifically with the American empire. Okay? Just when you have given up on Marxism, the Chinese socialists are becoming the world's greatest superpower, and you have bet on the wrong horse by deciding to live in the United States. Well, in my case, I don't live in the United States. In fact, I can't go back to the United States. and you can look me up and find out why. But just to address this fellow's questions, let's go one by one here. Okay. And so what do we have? Well, when money disappears, whatever food there is on the planet at that moment in time, right, is a measure of how much time humans have left as a species. Crypto is just another more abstract form of currency. Okay, so crypto is just one more currency that we've invented to do trade. Humans invented money when they invented trade, which was probably sometime around, the Neolithic, I would say, okay? Until then, we lived 90% of human existence, maybe more, maybe less, but thereabouts. We lived without trade. Trade was not part of our culture. And Chinese Empire, there's never going to be a Chinese Empire because first, the powers that be will not allow the Chinese to gain the upper hand, either militarily or economically. Okay, they're covering all those bases right now, and there might be a war because of that. There's always been wars because of economics, and that's probably what's headed our way. It's very likely, it's possible. Right now, the United States is much more powerful than China, and so Chinese have a lot of ground to cover. I don't think they'll ever cover it. I don't think they'll ever get there. Okay, there's not going to be like it's been in the past. People say, well, history repeats itself. It ain't going to repeat itself this time around. There will be no Greek Empire taking over the Persian Empire, no Roman Empire taking over the Greek Empire. None of that's going to happen. What's going to happen now in the last phase of man is that first the global economy is going to collapse before China ever makes it to becoming the great empire, the new empire. It's never going to happen. So China has wishful thinking if they think they're going to overtake the United States and become a world power. Well, I mean, the number one world power. It's never going to happen. Believe me, it has no chance whatsoever of happening. Okay, besides, countries or politicians, they learn from the past and they take precautions that the same thing doesn't occur again. Okay, and so if you thought that one empire is going to take over the other one, think again. Okay, we're too advanced in our understanding of history and military and economic issues to allow that to happen again. Okay, I think it's the same fellow. He says, I liked a lot of these because they're like a lot of people think out there. So it's important to look at all these comments and questions this fellow made. What makes you think that the whole world will want to do without money when money can be practically any type of object? Are we going to run out of objects? Okay, it's not that people voluntarily will say, well, I don't want to use money anymore. It's that money will have no value because we're devaluating it every day. And at some point, the majority or a great number of workers will not be able to make it to the end of the month with the salaries that they make. And so there won't be any purpose to work because they can't pay their rent and buy food and all the other regular expenses because they're just going to be over their heads with whatever salaries they get. And so we're approaching that situation where more and more people are going to fit into that category. That's part of the theory, okay? I never understand the idea of people thinking any modern civilization will lose social classes, governments, music, or any concept that has been occurring since the late Stone Age. It would be impossible to even force, let alone let it disappear on its own. Yeah, again, this is not an issue where it's going to be imposed on people or that people voluntarily will lose all these things or decide not to use them. No, it's going to be imposed by Mother Nature. Okay? Our global economy cannot continue expanding forever, specifically when the birth rate, the global birth rate, is falling. The man's artificial economy is based, it's a pyramid scheme, right? An inverted pyramid scheme. We expect more demand next year, companies do, and more and more and more every year. That's what companies look forward to. Demand is ultimately population. If population is not increasing, especially exponentially as it has in the past, and it's in fact turning the corner and becoming, reaching an asymptote, that spells trouble for the global economy. And that's where we're at right now. The population curve is asymptotic. That's the problem. Okay? Or that's part of the problem. Again, there are several more factors in there. What makes you think that we are no different than from any other animal when we are vastly smarter than the T-Rex and are able to make tools and control our birth rate, assist, not really true there, assist beyond our IQ limits, manipulate the genes of crops, create enough food to feed billions, and these capabilities and more are getting better every year. My God. But this is how people think. They really think like this. And so these are, let me answer that. Okay, here it is. Yeah, so how do we answer this fellow? We said, food is the only currency left when the traditional currencies vanish. No one trades food when the only thing of value is food. In the asphalt jungle, where there is nothing to hunt other than another human, food is equal to survival. So nobody trades that food, the only thing of value. Smart, intelligent, resourceful humans have no power or technology to do the following. We cannot travel out of the solar system, okay, alive, and that's a long story. I'm not going to cover it now. We cannot avoid density-dependent birth rates. In other words, what's that thing that's in parentheses next? Have children again. We're not going to have children, especially in the cities. City was not made for children. Okay, so in cities, that's where we all die. That's where we end our days. We cannot extend life expectancy to 200, let alone, I would even put the number a lot lower than that. I put 200 just to show that, people think that they're going to live forever, that technology somehow is going to make us live forever, something along those lines. No, it never happened and never will. Okay, so this notion that we're going to be living to, 150 years, 200 years, or maybe even forever, that's fantasy. That's all it is. It's fantasy in the minds of people. It's got to do a lot with the religion that we had for many hundreds, maybe thousands of years, where people wanted to live forever, and so they thought that after death you still have life somehow. Live forever. Your spirit lives out there. We cannot recover our genetic diversity. We've already lost it, and as a species, we cannot gain it again. No way of doing that. Again, I'm not going to go into detail there. We cannot live without food, water, or air, no matter how technologically advanced we are. Okay, we need food, water, and air. We are animals. I'm sorry, we're not plants. We're not trees or flowers or little plants there on the ground. We're not. We're not. Either stones or sand. We belong to the animal world. Okay, so again, you need food, water, and air. Those are the vitals. And again, we cannot live forever as a species either. Remember that all species have a beginning and they all have an end. Life does not live forever. To think that humans can live forever because of technology or some of these other factors this fellow mentioned is, again, fantasy. That's all it is. It's just an ideal that people have in their minds. Genetic engineering is wiping out the genetic diversity of plants. You cannot continue to have a banana and keep changing its genetic diversity to such a point where it's no longer a banana. Okay, so you either have a banana or you have something else. Create food for billions only as long as there is money. The day money disappears, we don't produce food for billions. We don't produce anything at all. Okay, so this notion that, we can produce, only because of money. That's how the human system works. Okay, not the ants, not the bees. The humans work that way. Okay, and so we have no difference from them, because in the sense, all we need is food, water, air, and that's what they need. And the only reason we have food and water is we produce it artificially. In other words, we plant it, we do something to produce it, and we only do it for money. So if money disappears, there's no one who's going to put their foot to the shovel. Okay, so that's the issue here. Again, not voluntarily, it's just the way Mother Nature designed it for humans. Okay, fellow here raises another issue. It was kind of funny. He says, talks about ruminants. Okay, so he says, man would go extinct by being unable to sustain the most important food source. Okay, what is that? Ruminants, which convert inedible plant matter into nutrients. Yeah, we absolutely need the horses and the cows, right? No, I don't think we ruminants have anything at all to do with the survival of humans. Now, do we need these animals to chew the cud for us? You know, again, we could probably do without most of the animals on Earth, maybe without all of them. We don't need the animals. Maybe we need them for pollination, that sort of thing. We could do that maybe artificially and grow our own crops. We could get rid of all the weeds that we don't need. We could get rid of certainly all the dangerous animals on Earth. We don't need sharks. We don't need lions. We don't need wolves. We don't need elephants. We don't need any dangerous animal on Earth. We have no need for them whatsoever. In fact, we probably would be doing them a favor, and I know a lot of animal lovers will kill me for that, by killing them, by murdering all the animals on Earth that are dangerous to humans. We don't need them. They're not part of our food pyramid. We need cows. We can grow them without lions. So we need pigs. We need chickens. We don't need them, but we do eat them. I mean, that's part of our diet today. But we don't need these other animals. Dangerous animals, why do we have them? Just to make fun of them? Just put them in a circus, in a zoo, hunt them, poach them? What's the purpose of having lions? And you might say, well, how about the beauty? Well, you can see it on YouTube. We've already filmed lions from every corner of the world. And so we know what a lion looks like we know what a mastodon looks like. Have you ever seen a mastodon, a real one? Have you touched it? Have you gone to the circus or to the zoo and seen a mastodon or a mammoth? No, we haven't. And we don't need to see them in real life. If you want to see one, well, you can go to a museum. They have all these, films of what they look like. We've reconstructed them. We can do the same thing with lions, with bears, with all these dangerous animals that we have no use for on Earth. And another person might say, well, how about the ecological balance of blah, blah. No, that's taking it too far. Just like when the mastodons disappear, humans did not disappear, neither did other animals disappear because, the mastodons or the mammoths disappeared. In the same way, if the lions disappear tomorrow, nothing will happen to humans. So this notion that there's going to be an ecological imbalance is, again, it's overblown. It's animal lovers. And yet those same animal lovers usually do not complain, or the other way around, they complain about insects because they usually are not insect lovers, especially some of these disgusting insects, that have weird, habits or societies or whatever. And they're afraid or they don't like these insects. But beautiful animals like, the majestic elephant and the lion and the tiger, we want to conserve those. So there's a double standard there, okay? So, you can beat me up, but just keep that in mind. These people are not consistent. Also, we have to be consistent. We're going to allow all animals to live. We got to allow the bacteria to live, that are killing us as well. We might as well let everything live. No, we kill bacteria that are harmful, and in the same way, we should be killing lions and bears and wolves and other animals that we do not need. Okay, sorry for the breaking the news, okay? Anyways, I used to be an animal lover. I mean, I love dogs and so on, but, let's be realistic. We don't need lions. That's the honest truth. Okay, a fellow says, food will go away when money goes away, okay? And that will happen because money buys less and less. Yeah, true. Now, it takes so much dollars just to provide the basic, yeah? All currency is spazzing out, okay? It all seems like temp and water lack or overabundance storms are making some popular crops unavailable. Resources have been squandered. The population is at an impossible number. Seems like we are functionally extinct already. Yeah, that's pretty much it. It's a good summary in many aspects of what I propose as well. I'm saying we are functionally extinct. We're not having children. That's one, because of density-dependent birth rates. So we're not having children anymore, and so, or fewer and fewer women are deciding to have children. which means that the population is not being replaced. There are still some countries where the population is expanding quite drastically still. But even countries like Nigeria used to have like seven, as an average, 7 children per woman and or per couple, and now it's down to 3. So if you look at some of these countries, their birth rates have dropped significantly, even in those that traditionally are known as, countries that put out too many kids. Those are stopping as well. Why? Because they moved to the cities. That's why. It's got nothing to do with NGOs or the United Nations doing something. In fact, recently there was an article on China, and it says that women in China do not want to have children. In fact, couples, men as well, don't want to have children. And so this notion that the new government or the government now put out saying that, well, we're going to stop this 1 child per family and we can have up to 2, and we're going to stop that too. Now we can have up to 3. Women say we're not even going to have 1. And again, it's because people have moved to the cities. There are economic constraints, culture changes. There are many factors that limit having children. And so people are not having children today in the cities. Whenever you go to the cities, children are out. It's the transition from the country to the cities that kills children. Okay? Don't listen to all these other people say, well, they have all these organizations that tell women, especially poor women, not to have children because they can't support them and this and that. No, it's got to do with moving from the country to the city. That's the globally. Okay, so as people move to the cities, they stop having children, irrespective of what happened in the past. Their great-grandfathers, their culture, whatever was in their culture in the past, when they moved to the city, they changed their culture, their economics, their habits, the whole works. Okay, so it's the transition from the country to the city that stops birthing. That's what we argue here in this site. Okay, along the same lines, a person says or asks, says about testosterone, says, why is testosterone declining? Is it because of the cities or because of genetic change? I think it's, and I always have exchange of words with my son, Hans, because he's more into the nurture and I'm more into the nature. Okay, so we do not see eye to eye on these issues completely. And what happens here is I believe it's that we've exhausted our genetic diversity. That's essentially it. And at the end of a species lifetime, right? When it's exhausted its genetic diversity, it has no way of regaining it again. And that's when it whittles slowly into death, unless a mass extinction gets them, right? And so I think that what happens towards the end is you have genetically similar individuals that have children, and those children come out wrong. They come out autistic. They come out with the wrong sexes, mixed sexes or whatever. These are all, as far as I'm concerned, these are all genetically engendered results. Okay? That's what comes out of mixing 2 people with similar genetic code. And so, yeah, I think that what's happening there regarding testosterone and all these things that we're having these days, men are also having fewer sperm counts and so on today. And I think it's all related to genetic diversity. We have exhausted it. So whoever you marry today is genetically, from a genetic point of view, is either your sister or your brother. And if you have sex with your sister, well, you might have a kid there, but either that kid or the next generation, there's going to be problems. Okay, and the Amish are a good example of that. In fact, I was in Iceland and I was pondering about the Icelanders, that maybe because, they came from the same stock of Vikings 1,000 years ago, approximately. Okay, today there's 350,000 inhabitants in Iceland. They've received immigration, of course, but most of them come from that Viking stock 1,000, 1,100, 1,200 years ago. And the question is, if they all, or a lot of them, or most of them come out of that stock and they've been intermarrying, the question is, at some point you would think that there's going to be some problems. And so I'm wondering if Iceland is having any problem. Of course, they have a relatively small population, 350,000, I think, in the whole island, more or less. So, it's something that needs to be studied, just like the Amish. Okay, another fellow brings up another issue. He says, get this thing here. What about the adverse effects of race mixing? For example, when Caucasian meets sub-Saharan African, as if humans met with Neanderthals, just on a lower scale. I think it's a little different, okay? And I'll get to that in a second. Sure, there can be offspring, but wouldn't a human of one race instinctively find another different, at least in nature, assuming we wouldn't live in this urbanized world? Well, the first thing is we can't avoid the urbanized world. And the second thing is that this is politics. This is not science. If you take a black man, a yellow man, a white man, a brown man, you take any of those, or if there are green men out there, fine, take them as well. And you put them together, we can have children. We can have children. A white guy like me can have children with a black woman. A yellow guy can have children with a brown woman, and any combination that you wish to see there. Why? Because we are the same species. What is race? Well, race, aside from the pigmentation and maybe other factors, is more a political issue, which is what this gentleman I think, this visitor, is raising. Okay, this is what you got to look at in science. Okay, and here we're going to compare science against, politics. This is more or less our genealogical tree. You don't have to believe in it, but this is what I work off of, more or less. I think there's been an evolution in humans from way back when, since, at least I would say since Homo habilis. Maybe he wasn't part of our lineage. I think there has to be someone 2 million years ago that was part of our lineage. Otherwise, we wouldn't be here. And I think Homo habilis is a good place to start. Then we went to Homo erectus, and we went through different intermediate, I guess you could call them missing links or semi-missing links. We've got some samples from intermediate periods. And we ended up where we are today. But some people say, well, we mixed with the Neanderthals, and what we have today is some Neanderthal blood from our great-grandfathers, the Neanderthals. Well, I think that's fantasy. That's nonsense. It comes from the genetic world. Okay, I think these two individuals, the Cro-Magnons or Cro-Magnon, and the Neanderthals, were very different species. They would not be able to breed or inbreed, right, or interbreed, and have viable children. And there you can see the skulls. I hope you can tell the difference between them. You can tell me which one is the human, which one is the Neanderthal. And you don't have to be an expert, believe me. You look at those skulls and you know that guy is different. Okay? You don't need to go to college to understand that. And so I think they were radically different in great measure because the Neanderthals evolved from Heidelbergs, who evolved from Homo erectus, in France, England, Germany, Spain. That whole region, I think, was populated close to 1 million years ago, maybe 800,000, 900,000 years ago. We have the site in Happisburgh in England, where apparently there was someone there, a 2-footed human or animal or whatever. Maybe it was a monkey, maybe it was a gorilla, but it looks quite a bit like Homo erectus. And from that fellow, 800,000, 900,000 years ago, came to Heidelbergs maybe 600,000 years ago, from which came to Neanderthals maybe 500, 400,000 years ago. That's more or less the picture that I have in my mind. Here's humans. They come from Africa. Again, that's my version of it. Okay, I like that version. I think humans migrated from Africa, met Europe at some point. They wanted to go into Europe. I think the Neanderthals killed anyone who crossed their border. I think they were locals. They had the climate in their favor. They were used to that climate. They wore no clothes. We had to go with clothes in there because we were cold, and we tried to hunt in their territories. They probably slaughtered us. And the only time that humans were finally able to make it across the border, maybe around 35,000 years ago, was when the Neanderthals went away, when they were extinct. And that was around 40,000 years ago, 5,000 years before we entered Europe. That's at least what the objective record shows, okay? So the first human that we have a skeleton has been dated to 30 in Europe. Was dated to 35,000 years ago, and the last Neanderthal, according to one study, an important study, by the way, says that the culture, the Neanderthal culture, disappeared sometime around 40,000 years ago. So you reach your own conclusions. That's my conclusion, that we never met the Neanderthals. We met them, but they slaughtered us. And the only time we really were able to get into Europe was because of they disappeared. And so I don't think we ever mated with them. But had we met them, well, it would have been kind of strange for, first communication. What do you say, ooga, 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 or something like that, to say, I want to sleep with you, lady. And then I don't think the human, if he had two eyes, he would have slept with a Neanderthal woman any more than you would have slept with a chimpanzee. That's more or less the way I see that. I think he would run the other way. So no, I don't think we ever mated. We were very different species. And being different species means that you cannot have viable offspring. That's my take on that. Okay, here's along the same lines, I think, species, race. People raise political issues rather than scientific issues sometimes. Try to tell a hotep that there is no genetic difference between races, and they'll tell you otherwise. What is a hotep? Well, it's a person who's either typically a black man, okay, because this really applies to white men and yellow men as well, okay. We're all racist down deep inside us in a way, or one way or another, okay. We see someone that's green and we say, well, that guy's different than me, in that sense we're all racist, okay. But this is what a hotep is specifically: a person who's either a clueless parody of Afrocentricity, or loudly, conspicuously, and obnoxiously pro-black, but anti-progress. These are black people who believe that sexist responsibility, politics, and gender roles are pillars of honor and tools to overthrow racism. As such, they consider gay and feminist agendas to be strategic attacks against the fight for black liberation. They overindulge in conspiracy theories about everything from aliens to the Illuminati, and tend to lean towards African motives and accoutrements in their day-to-day lives. A hotep is often deployed comically in black communities, especially on social media, in response to certain eye-roll worthy content. In other words, a lot of black people make fun of their own black hoteps. But a lot of what this says here, that came out of that article, by the way, and a lot of what that person says there applies to any race. We have whites which are like that. We have all kinds of all the races on earth have something like that. They have people within their race that think maybe their race is superior or hates the other race. There's all kinds of mixtures out there. So that hotep applies really to any race. I just wanted to address the issue of conspiracy theories, and all I want to say is that you got to choose your conspiracy theories selectively. You got to select them very carefully. Are there conspiracies out there? The answer is yes. There are conspiracy theories, and there are conspiracies by governments, especially by the U.S. government. And people say, no, how can a democratic government do such things? This is the culture of Washington and Jefferson. They wouldn't do those things, elected officials. And these people have a problem because they're not in touch with the real world at all. And here, I'll give you just one example. Okay, just one example here. And that's where the United States has admitted in doing a false flag. And that started the Vietnam War, or essentially ramped it up, okay, because there was a war already. But it's the Gulf of Tonkin, okay, and this incident that really, you could say, started the Vietnam War. The original American report blamed North Vietnam for both incidents, but the Pentagon Papers, the memoirs of Robert McNamara, And NSA publication from 2005 suggests that the dismissed by Department of State and other government personnel of legitimate concerns regarding the veracity of the sound of the second incident was used to justify an escalation by the U.S. to a state of war against North Vietnam. Okay, so the United States created this Gulf of Tonkin incident on purpose to be able to have a justification to have a war. And you say, well, government elected officials did this, okay? Well, it goes a little deeper than that, and let me show you here, okay? Give me a second here, because you're going to listen to a murderer, and that murderer is a president, or was a president of the United States, okay? And here it is. Give me a second here. I'll put it on because it's with sound, okay? Here it goes. It says 1961, Vietnam President Diem's brother shaking the hand of his murderer, future U.S. President Lyndon Johnson. November 1, 1963, the Diem brothers are arrested and murdered. November 23, 22 days later, JFK is murdered. And on August 2 and 4, 64, a few months later, Gulf of Tonkin incident starts Vietnam War.
They started with me on Jim, you remember. Yeah, he was corrupt and he ought to be killed. So we killed him. We all got together and got a goddamn bunch of thugs, and we went in and assassinated him.
Okay, so do American presidents murder people? Yes, they do murder people. And you say, well, that was the enemy, and they had to do it for political reason, for military reason, whatever. That's not the issue. That's a political. The facts are the U.S. presidents do kill people. Okay?
They started with me on
straight.
Jim, you remember.
And that's why they have
he was
organizations
corrupt and he ought
out
to
there
be killed. So we killed him. We all got together and got a goddamn
they're trained to kill.
bunch of thugs,
They're
and we went
murderers.
in
They're
and
professional
assassinated.
murderers. They're sent out there to do killings. Okay? So they kidnap people, they torture people, they do all that good stuff that you would not do to your friend, to your family, to your mother, right? So keep that in mind. To think that U.S. presidents don't do false flags and that U.S. presidents would not murder or order the murder of someone, think again. In fact, Obama said he watched the killing of
They started with me on Jim, you remember.
Okay, so,
yeah, he was corrupt and he ought to be killed. So we killed him. We all got together and got a goddamn bunch of thugs, and we went in and assassinated him.
They're all mafia. Okay, to say that, oh, I'm not going to even factor that it's never happened or never going to happen, well, you're very naive politically. Maybe your voting rights should be removed from you. Okay, maybe you should relinquish them until you learn a little more politics. Okay, here's another issue, fellas. What did you say? Yeah.
They started with me on Jim, you remember. Yeah, he was corrupt and he ought to be killed. So we killed him. We all got together and got a goddamn
what are your
bunch
thoughts
of
on how
thugs, and we went in
species
and
come
assassinated
into existence? Okay, that's an important question. Very important question. Scientific, right? Not politics. Evolution can explain how one species can diverge and become two different ones that cannot interbreed, but it doesn't explain the creation of the original. Okay, now I wrote that in my Neanderthal book, and here I can only give you these two fellows that I mentioned.
They started with me on Jim, you remember. Yeah, he was corrupt and he ought to be killed. So we killed him. We all got together and got a goddamn bunch of thugs, and we went in and
One is
assassinated
Thomas
him.
Morgan. The other guy is Theodosius Dobzhansky. He was a Russian who served under Mr. Morgan, his understudy or whatever. And the first guy says he discovered that the role of chromosomes and what they play in heredity. And the second guy, Dobzhansky, he came up with two theories. I think it was around the 1930s, 1940s. And he said a species is born in isolation, and genetic mutation.
They started with me on Jim, you remember. Yeah, he was corrupt and he ought to be killed. So we killed him. We all got together and got a goddamn bunch of thugs, and we went in and assassinated him.
Said. I came up with my own thought on this, and again, this is my graph down at the bottom, not his. Okay, the way a species is created, group branches off the mother trunk. Okay, and so they go into isolation, they go into a different environment, and now their mutation rate increases. It increases because they have to fight against the new
They
element.
started with me
And
on Jim,
actually,
you
I say
remember.
that
Yeah, he was
what's
corrupt and
happening
he ought to
is
be
that
killed.
other
So we killed
parts of
him.
their
We all got
DNA
together and got a
start
goddamn
working that
bunch
did
of
not
thugs,
work
and
where
we went
they
in and
originally
assassinated
were.
him.
That's what's happening here. And so the mutation rate increases as the group adapts to new diseases, climates, food, predators, etc. Okay, and now after that, once they become sedentary, essentially, all they can do is lose genetic diversity because all they're doing is inbreeding. They do this thousands and thousands of years, and what it is that you have all these bottlenecks. Okay,
They started with me
that
on Jim, you remember. Yeah, he was corrupt and he ought to
you have
be killed. So we killed him. We all got together and got a goddamn bunch of thugs, and we went in and assassinated
founders
him.
effects and then the bottlenecks, and a sequence of bottlenecks and founders effects is what slowly and surely whittles our genetic diversity. And here's an example of that. These are our ancestors, you could say, if you agree with them, Habilis, Erectus, and Heidelberg. Or in the case of
They
us,
started with
it
me
was
on
not
Jim, you
Heidelberg, it
remember.
was
Yeah, he was
Erectus
corrupt and he
to
ought to be
what is
killed.
called
So we killed
Rhodesian
him. We
man.
all
That's
got
the
together
guy
and got a
that's most
goddamn
closely
bunch of
associated with
thugs, and we
humans in
went in and
Africa.
assassinated him.
So the counterpart of Heidelberg in Africa was Rhodesian man. They found a couple skeletons of this fellow. But anyways, here you can see that a couple things. First, that Homo erectus, he lasted a lot longer than Heidelberg, who lasted a lot longer than Neanderthals. And not only did they last longer, but the guy that branched out of the Heidelberg is he came into a new environment, and from there, as he
They
was
started
dying,
with me on
the
Jim, you
Neanderthals
remember.
also
Yeah, he was
came out of
corrupt
their
and he
group,
ought to
and
be
they
killed.
encountered
So
new
we killed him.
environments
We
too.
all got
They
together and
became
got a
isolated from
goddamn
the
bunch of
Heidelbergs.
thugs, and we
Essentially,
went in and
this is my
assassinated him.
notion of how species are developed. Okay, and it's got to do again with Dobzhansky's theory that genetic mutations and so on, those are ones that play the crucial role. Isolation and genetic in combination. So that's my 5 cents worth on that. Okay, I think Mr. Dobzhansky was pretty
They
right on the
started
money.
with me on
That
Jim,
sounds
you
very
remember.
irrational to me.
Yeah, he was corrupt and he
Okay,
ought to
another
be killed. So
issue
we killed him. We
along the
all got
same
together and
lines
got a goddamn
says the
bunch of
Neanderthal did
thugs, and
not
we
die
went in and
off.
assassinated him.
Okay, the Neanderthal became us. Okay, on your mother's side, maybe. We will become whatever type of thinking creature will exist in the future. Okay. No, again, I don't think so, and I don't think the Neanderthals are us at all. Okay, here I show you the human skeletons that we found,
They
really
started
skulls
with
that
me
they
on
found out
Jim, you
there, the
remember.
Yerhud,
Yeah, he
the
was
Homo, the
corrupt and he
Adaltu,
ought to be
and
killed.
you
So
can see
we
the
killed him.
ages
We
there,
all got together
300,000,
and got a
195, and
goddamn
160,000
bunch of
years
thugs, and we
ago.
went in and assassinated him.
They are developing a chin, which no other hominid has. Only humans have that indentation in the chin. You can see the eyebrows are getting smaller. You can look at the one at the bottom. If you can tell me which one is the Neanderthal, which one is us, you'll see that there's a little difference in the brows, okay, the head structure and so on. So,
They started with me on
the
Jim, you
Neanderthals
remember.
were not
Yeah, he
us.
was
We were
corrupt
very
and he ought to
different than the
be
Neanderthals.
killed. So we killed him. We
You can
all
see it
got
in the
together and
head,
got a goddamn bunch
in
of
the
thugs,
structure of
and
the
we
head,
went
let
in and
alone the body. The
assassinated
body
him.
was also very different, okay, significantly different. So they had bigger bones and so on, thicker bones and so on. They were like weightlifters. Okay, I'm sure they never used clothes. There were too many differences for us to have mated with a Neanderthal. So that nonsense that the geneticists created that because we have 2.5 or 3% genetic
They started with me
material
on
from the
Jim, you
Neanderthals that
remember.
somehow.
Yeah, he was corrupt and he ought to be killed. So we killed
Okay,
him.
let
We
me
all got
show
together
the
and got a
audio.
goddamn bunch of thugs, and we went in and assassinated him.
Give me a second here. Sorry about that. I didn't realize that. Thanks for warning me. Okay, let me see if I say that again. A fellow asked about how species are created, and I'm saying that the first one is this. Fellows that studied the notion that that chromosomes play an important role in the development of a species. And in Dobzhansky there, he came up with a notion that first species develop in isolation, and maybe he wasn't the first one to say that, but he said that, again, genetic mutation plays a crucial role. And so I developed that chart showing that in isolation, at first, a species changes its genetic diversity, its genetic material quickly. There's a lot of mutations. And then once it stabilizes at some point and they become sedentary, then they can only lose it from then on, because all they're doing is inbreeding, unless they really mix with, some similar animal that they found out there, which is unlikely. Okay, I think essentially, they continue losing genetic material until they're all essentially clones, and then after that, they die shortly after. Okay, and here's another issue raised by this fellow. He says the Amish. He says the Amish have guns. Yeah, I know they have guns. The issue is that they don't use them to kill people, but this fellow says most of the Amish have great aim and will defend themselves. Not true, not true at all. In fact, World War I and World War II, they had problems with them, and they put a lot of these Amish in prison because they were not willing to go to war and fight. And so this notion that this fellow has that, the Amish will defend themselves is absolutely wrong. Never happened, never will. The Amish will not kill another human. You can kill all of them until they finally decide to, they'd rather go to heaven than kill you. Essentially, that's what it comes down to. Okay, another fellow says the AIs, artificial intelligence. We do a lot of work on that these days, okay? And do you think man's accelerated development could also be responsible for accelerated extinction? Well, your thoughts on general artificial intelligence. I think so. I think that the fact that we have, in the last 100 years, 200 years, we developed so much technology, and that was, you could say, exponential. And our population also expanded exponentially. Okay, so both were exponential. Our economics, everything expanded exponentially in great measure because the population expanded exponentially. But then at some point, population kept growing, but we turned a corner on technology, okay? Because manufacturing started dying as a percentage of GDP and as a percentage of labor. And today, it's almost all, 85% maybe, is services, all kinds of services. And what has happened to manufacturing, it's only about 15%. So anything you invent today, okay, it's just a modification on an existing thing, something maybe nice to have there that's not critical, and that's not going to put millions of people to work, and it's not going to overtake services as part of our economy. So yeah, I think there's been an accelerated evolution, both social, economic, and in population as well. There's a tremendous evolution that we've suffered in the last 100 years. And again, I think this conduces to the final curve for man. And as far as artificial intelligence, yeah, I don't have much to say on that. It does take away jobs. You have all these arms that do a lot of mechanical work that humans used to do. They do it faster. They do it more efficiently. They don't go on strike. They don't need to. You don't need to pay Social Security for them or anything like that. They don't go on retirement. And these machines work faster, more efficiently, etc. It's part of man's progress in manufacturing, but what that does is push people into services because there is no work or no more labor-intensive work necessary in manufacturing. So that's the only thing that we have on that I have to say about artificial intelligence. It's simply not. It's not in our favor. I don't even see it as something good or bad. I see it as something that is happening. We can't avoid it because we're trying to become more efficient, and it's going to have consequences. That's where I stop. It just is. It is what it is. That's it. Not bad, not good. It's just what it is. Okay, and yeah, we are moving into a world where we have a lot more automation. Okay, in fact, I just came from a country that's got tons of automation. It's unbelievable. Iceland is the most expensive country in the world, and I don't think I saw a single store where you don't do self-checkout. There's only one person manning the machines there. Everybody goes with their phones and just buys stuff and transfers money from, through the internet. It's just unbelievable. Iceland is very advanced in all those things. Only a country of 350,000 people, but it's very advanced. Okay, so here's some homework for people, whoever wants to tackle it. Okay, let's see if you can answer the question, or you do research and try to answer this question. Here's a question. Okay, read it well. It says, why did the fauna, right, in the seas disappear at the same time as the animals on land? More or less, maybe there was some time difference, but essentially they disappeared at the same time in the big 5 mass extinctions. Okay, because you can see a layer in the rock that suddenly all these animals are wiped out. There could be, some thousands of years, maybe hundreds of thousands of years difference there, but essentially they disappeared geologically at the same time. The question is, why? Can you come up with a mechanism? And hopefully you'll consider selectivity, okay? Because you got to explain selectivity. How does Mother Nature spare one animal and allow another animal to live? In other words, spare one species or set of species, orders, and liquidate the others. That's you got to factor selectivity in there. Okay, folks. So let's move to the lecture today, and it's got to do with whether an electron, and for that matter a quark, an atom, do those qualify as geometric figures? I mean, are we talking about spheres, balls? What are we talking about here? Is the electron a little tiny bead, a little round bead? Is it because that's how we always draw it, by the way. Okay, we draw it as a little point particle that goes around, And so I think a good place to start is finding out what a point particle is. How is it defined? What do we understand when we say point particle? And it's got the word point, which obviously belongs to geometry, right? The word point. Never been defined, but everybody uses it, okay? Okay, so let's start with a point particle. Let's find out what this is first. Okay, point particle, this comes out of the Wikipedia. Okay, it says an idealization of particles heavily used in physics. I don't know about physics, maybe in mathematical physics, which ain't physics at all. Okay, mathematical physics is one thing, physics is something else. Okay, the difference is mathematical physics describes and has ridiculous, irrational physical interpretations. Physics is part of science, and in science we only allow rational explanations. Okay, so there's a big difference. So mathematical physics is mostly descriptions, mathematical descriptions, and irrational explanations. Nothing at all to do with science. Its defining feature is that it lacks spatial extension. Well, if it lacks spatial extension, it looks like they're defining nothing, the word nothing, right? That's what it sounds like to me. When you say something that doesn't have spatial extension, no body, no zero dimensional, no radius, no diameter. What are you talking about? No length, no size. I think that's the definition of nothing, not of something. Okay, and so the question is whether you can do physics with nothing. Are you going to move nothing around? Okay, so it says being dimensionless, it does not take up space. Again, looks like they're defining space itself, which is nothing. Okay? A point particle is an appropriate representation of any object whenever its size, shape, and structure are irrelevant in a given context. that's got nothing to do with physics. That's got to do with math. Because the person is, or the mathematician, right, is only trying to describe something, and he doesn't care about what the thing really is. So it doesn't matter to him if it's a snake, a lion, a shark, a bird. He doesn't care because he's going to talk about mass, force, energy. He's going to talk about stuff that has nothing to do with physics, only to do with mathematical physics. And the physics part is too much. It's just mathematics. Okay? He's just going to be describing something. He says, I measured, and this is the equation. That's got nothing to do with physics. Physics, we have to understand the mechanism. That's what physics is about. And it says, far from enough away, any finite size object will look and behave as a point-like object. Well, that's an observer centered or related type description, okay? Because what they're saying is, if you're far enough, it looks like a little point. So, the Andromeda galaxy shows up as a little point in the sky, and it's bigger than the Milky Way galaxy. In the local group, the Andromeda galaxy is the biggest galaxy. And to our eye, it looks like a little dot in the sky, if you can see it on a good day. So the question is, are we going to look at what the observer perceived, or are we going to analyze what the Andromeda galaxy is, in fact? Bunch of stars, gazillions of them, rolling around a center. That's a little different than saying, well, it's just a dot in the sky. So these people are going to talk about the dot in the sky and how much mass that dot in the sky has. And that's good in math, maybe, but it's not good at all in physics. In physics, we have to deal with what the Andromeda galaxy is in reality if we're going to explain a mechanism. For example, how it spins, what its magnetic field looks like or does or whatever. That's what we're interested in physics, not in saying, well, it has so much mass and it pulls gravitationally on the Milky Way galaxy with such and such force and such energy. What is that? It's just a description. And again, observer related. In the theory of gravity, physicists, not physicists, but mathematicians as we call them, often discuss a point mass. Yeah, we don't care about point masses, meaning a point particle with a non-zero mass and no other properties or structure. Well, we got a problem there because if it's a point mass and it's got mass, and they're saying it's got no size, it's actually nothing there. Well, how can nothing have mass? And I thought mass, the definition of mass was, that it's a quantity of matter or a measure of quantity of matter. These people say it doesn't have any matter because they don't care about the object itself. They don't care about the body. They're not going to be dealing with the body because they have no purpose for a body. They can't put a body in an equation. So what are they going to put in there? Well, it's weight, it's mass, it's length. Okay, whatever. They're going to put a number in there with a unit. And so they don't care about what the thing itself looks like. And that's going to haunt them in both relativity as well as quantum mechanics, not to mention string theory, which is also a mathematical theory, by the way. Not even a theory, it's just a description. Theories are explanations. Explanations are theories. In quantum mechanics, an elementary particle, also called point particle, such as an electron, quark, or photon, is a particle with what? No internal structure. The size of an elementary particle is exactly 0. Okay, so here we're dealing with physics. Physics, first and foremost, requires an object. You can't do physics without an object. What is there to see? What is there to measure? What is there to experiment in the lab if you consider experiments part of science? What are we going to do with a zero-dimensional nothing? So no, that's not true for physics. In physics, we need an object. That's the first rule of physics. These people are doing physics without objects. That's the problem. Okay? And yeah, we have a little bit of problem with that when people start doing physics without something, without a thing in front of you. Okay? So what the mathematicians have invented, okay, is this thing called infinitesimal. Infinitesimal. And what is infinitesimal? Well, as you can see, it's a mathematical notion. Okay, and they apply it to size as well. The farther you go, the smaller Andromeda gets. The farther you go, the ant gets smaller, and so on down the line. You know, you want to see your pen look like a little dot? No problem. Just put it out in the horizon in the distance, and your pen will look infinitesimally. Okay, infinitesimal. So it says infinitesimals or infinitesimal numbers, right? What are we talking about? Math, right? Quantities that are closer to zero than any other standard real number, but are not zero. So they have this notion where something approaching zero in any sense could be in the zero size, zero mass, zero length, zero radius. As it approaches zero, they say, well, that's infinitesimal. The problem with the word infinitesimal is they use it as a synonym of zero whenever it's convenient. So when you want to say zero sometimes in math, well, you say, well, it's infinitesimal. It's getting infinitesimally smaller. Okay? And again, that's an observer-related issue. It's like, I can't see the atom, so it's infinitesimally small. Okay? That's how they deal with it. But then they say, well, it's a point particle. Oh, what's a point particle? Well, it's one that has no size. So now we went from infinitesimal and we equated it to zero size. You see how this is, how the language is used in mathematics, in mathematical physics? They equate infinitesimal many times with zero. And they give you the idea that, well, that's an infinitesimal particle. And you say, okay, I understand, that's a very small particle. But then they jump the river and they go on the other side and they say, well, it's a point particle. Oh, what's a point particle? Is it an infinitesimally small particle? No, it's a zero size particle. No volume, no nothing, except mass, charge, and all the other good stuff. Okay, because the body is not important for a mathematician. Okay, and there's another version: incalculably, exceedingly, and immeasurably minute, vanishingly small. Okay, so those are the notions people have with this strange word called infinitesimal. And parallel to that, I mean, where did they get all this stuff, or how are they using this? Well, here you see how calculus developed, essentially, okay? And it has to do with this notion of the limit, okay, that they've created in mathematics. It's you could say it's the foundation of calculus. It's the value that a function approaches as the input approaches some value. Okay, and so as x approaches zero, what happens to f of x, the function of x? That's essentially what it's all about. And this is what they turned into this infinitesimal thing, okay? Because they're not concerned, again, about structure or body or things. They're just concerned about doing calculations, and that's how particles became infinitesimally small, meaning point particles, meaning zero size, okay? So what particles do we have? Well, we have these electrons, and they are point particles. They're considered to be point particles. In other words, zero size. Why? Because they're not going to take the size or the diameter or the radius of the electron into consideration, or if it's got constituents, something smaller than that comprises the electron. Okay. And that's not the only one. You have the gluons, you have the quarks. They're all point particles. They're all zero-size particles. Why? Because they can't see them. And so they say, well, they're there. We don't know their size. We don't know their diameter. We don't know what they're made out of. And they just call those point particles or elementary particles or fundamental particles. These are the words that they use. What are they referring to? Infinitesimal particle, meaning zero-size particles whenever it's convenient, whenever it's useful. Okay? So this is how the language is going to be treated. And if you're not careful, you may be hearing one thing, understanding another. Okay? So here's an infinitesimal particle. I mean, you know, how they determine these things sometimes is, for example, a specific case, Ernst Rutherford, he went in there and he shot particles at what he thought was a gold foil, which he thought was primarily, full of holes or whatever, but there was obviously material. He expected some of these particles to go through, something bounce back. But, some of them hit right in the center and bounce back. And so he says, oh, there's something in that center of where this particle hit. And he figured out that way that an atom is mostly empty space because most of them went through, but some of them bounced against the proton, which was allegedly in the center, or against some nucleus in there comprised of protons and neutrons, and the particle bounced back. Okay, it's that backscattering experiment. Well, here's a case that I can show you. Okay, here's a spider's web, and the spider's in the center. And you take some tiny, very tiny pebbles, and you throw it at the spider and spider web. Well, if you throw it through the holes, between the little web there, the particle goes through. And when you throw it at the center, you'll probably hit the spider and the particle bounces back. Your little grain of sand or whatever you threw at it bounces back. So does that show that the web does not exist there, that it's mostly empty space because most of the grains went through the holes? They could even rip some of those little connections there because maybe they're not strong enough to withstand a pebble, and so it goes through, and you say, okay, they all went through except when I hit it in the center and then it bounced back. Does that prove that the proton, the center of this web, is a solid particle? Or does it prove maybe, or could it be interpreted as being a web, okay, that, and we just managed to hit the center. And when it hits the center, it bounces out back to you. And when it doesn't hit the center, it goes through. So is the atom like that? Maybe it's not all empty space, as Mr. Rutherford concluded. And what if it's like this? Okay, here we have the 3D version, okay? 3D version of a spider's web, okay, all over the place. And so you shoot a particle, and it turns out that it goes through most of those holes, but when you shoot it in closer to the center, well, it bounces back. Now, if the atom looks like that, did you figure out that an atom is just a little dot in the center and another one rolling around, which is what the planetary model says? What if an atom looks like that, somehow like that, somewhat like that? So again, this notion that perhaps we have a little tiny bead called the electron rolling around somewhere in the what is known as the energy levels of an atom, the orbitals, and at the center you have the proton ball. And then in between you have absolutely nothing, which is the planetary model. Even to this day, that's the one they use for electricity, for ionization, for quantum jumping. Maybe they've got the wrong model. Maybe the model has to be looked at again, revised. Okay. Here's the proton today. Okay, let's go with that first. Okay. And the proton is made of these 3 quarks. But it turns out that the quarks are point particles, according to the standard model. If you look it up, you'll find out that the quarks are point particles, meaning no size. And by the way, they're held together by these bed springs. I call them bed springs, and they're known as gluons. They're these strong force. They mediate the strong force. And those bed springs are also regarded or considered or taken to be zero-dimensional. In other words, they're point particles. So we have this proton, and it's made of 3 quarks, point particles, nothing there, which are held together by bed springs, which are point particles, which is nothing there. It sounds like the proton is absolutely nothing. And yet the proton is said to have a diameter, a radius, and it's made out of these 3 nothings, which are held together by lots of nothings. Bunch of point particles everywhere. Does that make any sense? Because that's what that's the official version of quantum physical interpretation. They have no idea what a quark looks like or what a gluon bed spring looks like. Okay? They treat them as point particles, except when they have to draw them to mislead you to think that they've got the right physical interpretation for what happens inside a proton, or a neutron for that matter, because they're also made of 3 quarks. And here's the proton in action. Okay? That's what it looks like. So they had these zero-dimensional bed springs holding together 3 zero-dimensional quarks, and all of this zero-dimensional nothingness is what the proton is, or made of, or whatever. So you figure out what a proton is. And that's the proton, which is the big guy. Let's look at the electron now, because that's the one we're going to be analyzing. Here's the Swedish electron. Okay, you say, Swedish, Bill? Yeah, Swedish university proved, filmed the electron in motion. Here it is. Okay, oh, fell on the other side. Hold on, give me a second. Where'd he go? I lost it completely. Oh, here it is. Give me a second here. There it goes. Okay, here's the Swedish electron. Okay, that's what they filmed. And this is a real film, okay, that they claim to have made. What did they film? If the electron is a point particle, zero-dimensional, no volume thingy, that's got mass, no structure, no body. They filmed it, and then they say it's, what is an elementary particle? Is one that is not made of smaller parts. Fundamental particle is not made of anything. They cannot figure out what it's made out of, so they say it's not made of anything. It's like the buck stops here. You know, this is the particle that makes up everything else, so to speak. And there you see all these little lines, like if it were made of little pieces. This electron has different layers. It looks like nested layers. What does it look like to you? They say they filmed the electron. How could they film the electron if it's zero-dimensional? How can that be the electron if it's a fundamental elementary particle, which means it's not made of anything, when this one is made of, obviously, patently, made of all these nested whatevers, whatever those are. Okay, so this is the issue. These people just print that, and people buy it like candy. You know, they say, oh, okay, they proved that they... In Sweden, they should get a Nobel, and so on down the line. What are we staring at? Is that an electron? What is that? How can they film an electron? And they say, well, we did because we had these fast cameras, etc., etc., etc. And then they define the electron as a zero-dimensional point particle. Aside from the fact that, you know, the electron moves around the proton, right, in the hydrogen atom. And okay, let's concede that. Then why doesn't that electron fly away? Why does it fall to the nucleus? What keeps it bound around the proton? That's the issue. Okay, so all these issues have never been answered, and they never will be, because, you know, the model is screwed up. Okay, so here is the model they show you. They show you something like that. You get the 3 quarks in the center forming the proton, okay, and you have the electron, blue one there, going around. As you can see, it's going from energy level to energy level, from orbital to orbital, okay. As it falls, it releases energy. That's that green arrow going out there. And when energy comes in, it pushes the electron to a higher level or higher orbital. That's the model, that's the official model. And you'd say, okay, so is that that's the model with which we operate? Well, the problem is that if all these are zero-dimensional, this is what the model looks like. And I'm being kind with a proton, because there shouldn't be a proton there if it's made out of zero-dimensional particles. And the electron, you know, I don't know where that went, because it's zero-dimensional. We have a zero-dimensional nothing orbiting at different orbitals, which are concepts, a particle in the center, which is made of nothing. We have 3 nothings, known as quarks, and they're held together by 3 nothings, or many nothings, known as gluons. That's the quantum atom. That's the official quantum atom. Okay, so what should we conclude? Well, Is the electron a geometric figure? Does it qualify as a, I don't know, a sphere, a circle, maybe a cube? I don't know. I mean, let's find out. These are the conclusions. Okay. The quantum electron does not qualify as a geometric figure, okay, under any definition. Okay, we have the Euclidean definition. He defined that a figure is that which has a boundary, and boundary is that which is the border of a figure. So he had a circular definition, but electron doesn't fit either of those two descriptions. Okay, the electron fails the C-touch definition of figure of mathematical physics. That's the one mathematical physics operates by. That's the one they use. That an object is that which you can see or touch. You can't see the electron, you can't touch it, especially a zero-dimensional one, so it fails that definition as well. The electron fails the shape definition of science and physics, which is that which has shape. Something that has 0 dimensions is not a something. Okay, no volume, that's not a something. It has to have volume, it has to have shape. It's got to be something there. Otherwise, it's not an object. And if it's not an object, it doesn't belong in physics. Maybe in math, I don't know. I don't know what they do over there, but that doesn't belong in physics or science. And then the electron is specifically defined and described as a zero-dimensional point or elementary or fundamental particle. Okay, so that's the electron. That's the formal definition of that. And so or description. So if that's the description of an electron, you know, again, what are we talking about? We're talking about nothing. And so the conclusion is the electron is a non-entity, let alone a figure. It's nothing. So far we have nothing in front of us. Okay? And so let me show you the electron, the famous electron, see what it looks like. The one from quantum, okay? I'm going to show you the quantum electron. Here it is. If I can get it up here. That's what the electron looks like. Right underneath the arrow, okay? So if that's a geometric figure, as far as you're concerned, well, then you do have it. You know, you have the electron is a thing. It's a figure. Okay, but if you see nothing underneath there, well, then the electron is absolutely nothing by definition and by description, and also, you know, the way they use it, because they don't care about bodies anymore. They just care about what number they're going to put in an equation. Okay. Okay, let's move on to questions that people made and comments. Here's the first one. It has to do with black holes. Remember, we stopped with black holes the other day. That's what we analyzed, whether a black hole is a geometric figure. Okay, so fellow raises this question, says the simplest static black hole have mass but neither electric charge nor angular momentum. Okay, I think he got this out of the Wikipedia because it says something very similar. These black holes are often referred to as Schwarzschild black holes. Some black holes are very tiny but have mass of a large mountain. Another kind of black hole is called a stellar. Okay, there are many stellar black holes. Supermassive black holes exist in the center of most galaxies. Again, all this is taken directly out of the out of the mainstream. Okay, this is what everybody puts in their blogs and their articles, and it's just pasted on here. That's essentially what it is. They are astonishingly heavy, with masses ranging millions to billions of solar masses. Typical stellar blah 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 blah. Okay, that's not the question. Let's answer the question that this fellow has to address. This is the only issue a fellow has to address, and that's the one Mr. Hawking raised, okay? And here it is. This is the formal, this is the official version, okay? This is the party line, and I'm just going to read that part out there in the center. Infinite density. Eddington thought it was simply not possible that a star would collapse to a point. Einstein himself wrote a paper in which he claimed that stars would not shrink to what? Zero size. And Chandrasekhar won the Nobel Prize for proving mathematically that a black hole collapses to zero size. So the question is not all these other things where they say, well, these are all the different kinds of black holes that are out there, the stellar one, the small ones, the big ones. No, we want to know what a black hole looks like, and if a black hole looks like zero-dimensional, zero size, zero nothing, all we have in front of us is nothing, absolutely nothing. That's the issue that you got to address. Another fellow says, I like this one, made me hungry. Okay, fellow says that black hole looks like a donut. Says the black holes isn't a hole, it is a donut. See, we have all these notions out there people have. One guy thinks it's a ball, the other guy thinks it's tiny, infinitesimal, this other guy thinks it's a donut, and so on. We have all these weird notions out there. Where do these people get these things? Who knows? They just read, one guy reads over here, the other guy reads over there, and they all get it wrong. Okay? It is a torus viewed from the side where you can see through the middle. There are no black holes. So looking at a donut, we don't say, oh, look, a zero-dimensional donut hole. No, we say, oh, look, a donut. But that is insane, upside-down world we live in today. Well, yeah, obviously, because we need to figure out if a black hole looks like that, like a donut, or the whole of the donut, or like nothing, like zero-dimensional nothing, because Mr. Chandrasekhar said it collapses to a point, meaning to zero, because that's what his calculation showed. Okay, so what does a zero-dimensional entity look like? That's what we want to find out. Okay, another fellow along the same lines, also with black holes. There's a black hole day. Okay, questions for black holes, comments. Fellow says, at the center of the torus we have extreme amount of mass. It simply isn't nothing. Okay, then what is it? How would nothingness attract what is around it? Yeah, how would it? This is what I want to know. How does nothing attract anything around it? So don't ask the question, answer the question. You got to answer the question, because these people are saying it's nothing, and you're asking a question like saying it's got to be something, because you're wrong, Bill, because otherwise it wouldn't attract anything around it. But these people say, not me, these people are saying that it's nothing. It's zero-dimensional, zero volume, infinite density. So the question is, how does nothing, which is what I just described, pull on anything? How do you produce gravity with nothing? That's the question that you have to answer if you're going to vouch for the black hole, because a black hole is defined, described, and taken to be nothing. Okay? And so here we have my great turtle thing. Here's the turtle rotating around mass. What is mass? Well, mass is a concept. Okay, and here you have the famous space-time sheet. And of course, there is no such monster as space-time, so the turtle is really going around nothing. And if you remove the mass because there's no object in the center, well, what the hell is the turtle going around? What is pulling on the turtle? So that's the question people have to answer. Okay? Yes, black hole is defined as nothing. And until you get your brain around that's what the mathematicians are saying, that a black hole collapses to zero volume. There is nothing there. There is no body. It crushes all matter out of existence per their own words, their own descriptions. What do we have left? We have only mass. What is mass? A concept. It's like saying the elephant's not there, but the weight of the elephant is still, ghosting around. It's still a phantom. That's what these people are saying. Is that physics? Okay. And one fellow tries to define nothing in that same context. Okay, he says nothing to me just means that which cannot be measured or seen. No, that's not the definition of nothing for two reasons. One, you're introducing an observer. You never define words using observers. Okay, not scientific words. You can define time like that. Time is not a scientific word. We don't care about time. That's something that concerns only the mathematicians. And there you need an observer. But to define all these other words such as nothing, no, you don't need an observer. You need to figure out what nothing is in the absence of an observer. And so nothing, that which does not have shape, which lacks shape. Okay, that's the definition of nothing. So a black hole is nothing because it's that which doesn't have shape. Okay. Another fellow says that a black hole really looks not like a donut, it looks more like a drain. Hello, all these notions that people have about black holes. Perhaps the black hole is a drain hole. Well, to drain into what? Because a hole has to be in something that is physical. something that has shape. Then you can put a hole in it. But if you have absolutely nothing, you want to make a hole in nothing, well, I don't know. It doesn't even work in golf. Okay? A sink drains hole that is open and the water drains out. Black hole is of the same nature objects are escaping and draining into. Okay, in a black hole, what is the object draining into? Your guess is as good as mine. Yeah, I know, because people don't question these things. These are coming from Harvard and what is it, Cambridge, and people don't question these. People say, well, no, because all these mathematicians, they can't all be wrong. Well, what is a black hole? Please ask them to draw it. Don't tell me, how much mass it has. Who cares about that? I want to know what it looks like. That's got to do with physics. But to say that it's big, that its event horizon is so it's got so much radius or diameter, and that things fall in at such and such rate, at such and such velocity. Who cares about all that? I want to know what a black hole looks like before you begin your presentation. Okay? We need to know what it looks like. And if you tell me it's zero-dimensional, you have not defined or described a black hole. You've defined nothing, the word nothing. That's all you did. Okay, fellow says, okay, so everything that takes up space and has mass is matter. Aha. But a black hole crushes all matter out of existence. Okay? All matter is made up of atoms, yeah, which are in turn made up of protons, neutrons, and electrons. Yeah, we agree. The more atoms per volume, the higher the density of the mass. Okay? At the center of the largest black hole resides the highest density of mass. Density of mass? What are you talking about? If mass relies on matter and the black hole crushes all matter out of existence, what mass can you possibly have? So where's this mass coming from? Is it a ghost that God sends and says, I'm going to give 1,000,000 kilograms for that mass in the center over there in the middle of the nowhere? So what is occupying that space if a black hole is zero-dimensional, zero diameter, zero nothing? Okay? They certainly are absolutely nothing in zero dimension without shape. How would that attract what's around them? Again, same issue, And so, I like to put this out. Give me a second here. Got to get them all the way from the bottom here. Okay. And here's the first answer. Okay, this comes from David Harrison. He's a physicist, mathematical physicist, mathematician. And he wrote a paper or an article called Black Holes, University of Toronto. And he said, if the mass of a star is greater than about 3 solar masses, it goes through the neutron star stage and keeps collapsing. In this case, the gravitational attraction is so intense, the neutrons are literally, crushed out of existence. No more neutrons. Their structure is gone. We call that object a black hole. I characterize a black hole as an object whose gravitational pressure is so intense that the matter of the object is crushed out of existence. The matter is crushed out of existence. There are no protons, no neutrons, no electrons, no atoms, no nothing. They're crushed out of existence. So what's left? A ghost, a soul? You kill the body and the soul goes to heaven? Is that what this is about? Is this some religious stuff? We can calculate the Schwarzschild radius for the mass of the Earth. It works out to be about 1/3 of an inch, okay? What this means is if we could compact the Earth so that its radius gets down to 1/3 of an inch, the gravitational attraction becomes so strong enough that Earth gets crushed out of existence, creating a black hole. It's always crushed out of existence, crushed out of existence. There is no matter in a black hole. So, we end up with what I call the circular argument of black holes. Okay, here it is. Here's the circular argument, okay, so that you memorize it. Black hole of mathematics. You start out with a black hole, it's only mass. But it turns out mass is the quantity of matter, it requires atoms, etc., etc. But a black hole crushes all matter out of existence. So what do we have? Well, a black hole is only mass. And what is mass? It's a concept invented by the mathematicians. It's a number. It's a value. It's got no place in science. Okay. In science, we have to figure out what the object looks like. We can't do physics without objects. You need a thing to do physics. Without thing, you don't have physics at all. Okay. Another issue, another question person asks is, because something is in motion doesn't rule it out as an object. Well, no, of course not. Your body is in motion. Did your body suddenly disappear into the concept zone as you move? No, it's in reverse. See, you got to have an object before you can talk about motion. But now you're not talking about objects, you're talking about motion. Okay? The subject matter is motion, not object. And just because it moved, it didn't become a concept, because the concept is motion, not the object. Now you're talking about different subjects. Suddenly you've drifted into the subject called motion, and motion is a concept. Okay? So we're not talking about an object. An object stands still. You point to it and you identify it and you say, that's an object. Okay, we're done. Now you can talk about motion, weight, measurement, whatever you want to talk about. But first you got to identify the object before you move anything. Okay? So it's not that the object becomes a concept because it moved. Motion is the concept, not object. Okay? Should not be confused in which part of the dissertation you're at. Okay, here's another issue. It says, a cube is comprised of 12 line segments, 6 squares. Is that a cube there, those 6 squares there? Is that a cube, 12 lines? And it turns out that, you know, if that's what a cube is, 12 line segments, right? Not lines, but line segments, or 6 squares, and a square is hollow. There's nothing there. It's just a square is just 4 lines. There's nothing in that window. There's no window pane, no glass. Okay. Then what you have when you build your famous cube is a hollow, not a solid. That's not a solid. That's a hollow. That's what a cube is. And it turns out it's even worse than that, because those lines are made of points. What is a point? Is a point a little dot? Is it a geometric figure? No, point is a location. So we have a bunch of locations forming the so-called lines that form the squares that form the cube. All we have is a bunch of a big itinerary, a squarish or cubic itinerary. All we have is a perimeter. So if that's what a cube is, it doesn't belong in geometry. Geometry begins with shapes. You need to have a thing there. And those aren't shapes. Those are itineraries. They're location, a bunch of locations. That's all we have there. Okay, another fella brings up an issue. He says, you can't explain with, you cannot, right? You can't explain without describing. Yes, you can. You don't need to describe, and for that you need to define what explain and describe mean. You need to define these terms in physics, in science, right? You need to define these terms. You can't just say whatever comes out of the top of your head, okay? And so explain, what is it? It's to theorize, essentially. The causes or reasons, in case of philosophy, underlying a phenomena. And second version of that would be how, you know, in physics, a consummated event happened. As an explanation deals exclusively with the past, you only explain consummated events. What's described? What's description? A listing of properties of a physical object. Okay? In science, adjectives describe objects and adverbs qualify or characterize motion. Okay, so first we have to find out the difference between explanation and description. Okay, and so let's see what we have in science. Do we need to describe in order to explain? Well, not really. Here you have the scientific method. Okay, science is rational explanation. The scientific method requires that you have the objects, the definitions, and the initial scene, the first frames of your film on which you're going to base your theory, your explanation. Nowhere do you see provision for description. You need objects and definitions. Okay. Now, the initial scene, yeah, you can describe if you want the initial scene, but that's not the theory. Okay. We call that an assumption, not a description. Really, what we're focusing is on the meaning of what we're presenting as our first frames, the initial scene. Okay, and then comes the theory, which is the mechanism and then the causes of what caused the event to happen. So no, first you need to differentiate between description and explanation, and no one has ever done that. We had to do that in rational science. Explanation and description are not synonyms. Okay, another fella asks lots of questions because it took a long time to answer them, so we collected them. Okay, and here it is. Says you say mathematical physics is irrational. Yeah, the physical interpretations of mathematical physics. Okay, is mathematics without physics rational? I would say that it should be logical. Okay, the illogical, the irrationality comes when you try to merge math with physics. Mathematical physics, that's an irrationality. Math is math, physics is physics, never the twain shall meet. Math describes. And as long as you describe and you use an equation, you want to do measurements, that's fine. Keep it in that realm. Don't mix it with physics. Physics is something else. Physics, you have to explain something. And mathematical physics becomes an irrationality because they're using the descriptions, the mathematical descriptions, to reach conclusions about how the universe works, how Mother Nature does her stuff. That's where we have a problem, because you cannot extrapolate whatever descriptions you have in mathematics and turn them into explanations in physics. And at the end of it, say, to top it out, the icing on the cake, say, well, we didn't understand any of that anyways, but let's continue rolling. No, that's not physics. That's not science. That is irrationality. That's poppycock. That's what it is. No, math is math and physics is physics. You got to keep them apart. Math is a logical language, but it's a language that is very limited. Okay? The language of mathematics is only used to describe quantitatively. Chinese, Greek, English, Spanish, Russian, any language you can think of out there, they have the ability to describe and explain qualitatively. Something that mathematics cannot do whatsoever, never will, never can. Okay, it's impossible. You cannot use the language of math to explain how this universe works, the causes, the mechanism. For that, you need a superior language, which is Chinese, Greek, English, Russian, any of those languages that you can think of. You can even use Icelandic, which is you can't understand that Viking language at all. Yeah, you can use any language to talk qualitatively. You can't use math to talk qualitatively. And that's what mathematical physics attempts to do, to explain things about the real world, extrapolating notions from mathematics such as force, mass, energy, which have nothing to do with a qualitative world. It only has to do with a quantitative world. Okay? So that's where you got to draw the line. So yeah, do not confuse math with math phys. Okay? Those are two different things. It's math phys which is irrational. Mathematics is a logical language. That's all it is. Quantitative. Only purpose is quantitative. Okay, and a fellow complains about dimensions. He says, I was reading and came across this. Biotic diversity is huge, complex, and multi-dimensional. Yeah. And these dimensions include kinds of organisms, numbers of organisms, how organisms are distributed, etc., etc. You can really tell from this man's writing just how they treat dimensions as number lines. All 4 items on that list are number lines. Yeah, he's right. They talk about infinite dimensions. What do you mean infinite dimensions? What does that mean? Well, it means that it could be the dimension of temperature, of mass, of whatever. You can put anything you want there. It's like any measurement falls on a dimension of under this notion because it's a number line. That's what it is. And so you can use a number line, for example, for temperature. And you can put little check marks there, little marks, and put numbers underneath them and talk about, the units, centigrade or Fahrenheit or whatever you want. What are you talking about? Are you talking about a dimension, length, width, and height? You know, how things point, or whether they are orthogonal to each other? No, you're talking about a number line which has no direction whatsoever. It only has magnitude, and that is what is called the number line. And what these people have done is they've taken these number lines and called them dimensions, coordinates, and vectors. They use the words of physics to apply them to the number lines. Otherwise, they wouldn't be able to tell you that space-time is four-dimensional. They would have to say, well, space-time is four number-lined. And you say, well, what did you say? What do you mean four number-line? What does that mean? But if you say four-dimensional, say, oh, okay, I see, and I can see why I can't understand them or why I can't see them. This space-time, because it's four-dimensional, that's beyond my capability. I can only see three-dimensional. Now, if they called it four-number-line, people would say, what the hell is that? A four-number-lined object? That's how you would get them. So you got to make sure that you understand that these people are talking about number lines and not dimensions. But they use the word dimensions, and people think they're talking about a four-dimensional, unimaginable object, obviously, because no one can imagine four-dimensional object. And they say, well, it's beyond our capability. Like for flat earthers, it would be to imagine our three-dimensional solid world. That's the analogy they use to drive it through your head. Yeah, they're using the word dimension when they should be talking about number lines. That's what they are. They don't have dimensions in physics, in mathematical physics. Okay, another fellow says, why magnetic thread not clash against electromagnetic rope around the magnet when magnetic threads spin? Well, again, the big problem here is that people are talking about see and touch. They think that an object is that which you can see or touch. And so they say, how come these two things don't touch, in this case, right? Each other. Meaning, they go through each other, but that's not the point. The point is, they don't even touch. So they say, how come they don't touch? Well, they don't touch because the definition of the word object has nothing to do with the word touch or with the word see. The definition of the word object is that which has shape. The thread, the rope have shape. Period. We're done. They're objects. They don't have the property of touch, and certainly we cannot see them. We cannot see atoms. These are orders of magnitude thinner, smaller, whatever. So you cannot see or touch them. Okay, so don't bring in touch or see into the conversation. Whenever you do, you're thinking in ordinary, everyday terms where you see and touch things. And yet, still, in that case, you can't see the air. Does that mean the air is not a physical object because you cannot see it? So again, you got to see and touch are the problem. People confuse the word object with the word see and touch. They think that an object that you can see or touch, and that is not the definition of object, and that's where people get confused. Okay? You got to define these terms scientifically in order to use them consistently in a dissertation. Okay, another issue, fellow says, an alternative explanation for Compton's effect. Okay, Compton's effect, well, let's show you here. Maybe a picture is worth 1,000 words. Okay, and here's the version of quantum mechanics versus the version of the rope model. Okay, so here it goes. Okay, the one on the left, quantum mechanics, one on the right, rope hypothesis, and you can see in quantum mechanics what they have is these balls. They could be also waves. And they come in, they hit an atom. And what comes out on the other side is is on one hand you have current and on the other one you have light. The red balls coming out of there are current, and that's because the incoming beam hit an electron and forced it out of its shell. Okay, so this electron is now flying, and many of them form a current. All these electrons are moving from atom to atom, okay, and that's your current. What happens on the other side? Well, you have light, and what's happened to light is the wavelength gets longer, meaning frequency changes, okay? What is the rope model? Well, what you have is a rope. Again, that's light. There's no balls or waves coming in. What you have is a torquing rope. Because the rope torques, it compels the electron, but really the atoms that form the material that you're hitting against, which is polished metal. Okay, it forces the atoms to spin in a given direction, and it aligns them, and that's what forms current, because all these electron shells are merged and they're spinning. They're spinning either clockwise or counterclockwise, depending on how the signal came in. And that's what's going in one direction. That's what we're going to call current. What happens in another direction is what we call light, which is a longer wavelength, shorter frequency light, okay, electromagnetic phenomena, because the electron shells that to which the first beam came onto made it go slower. In other words, the signal moving along the rope, going downwards there, light, the signal is now lower. Why? Because the frequency has lowered, and what's increased is the wavelength. Okay, so the effect is the same thing as in quantum mechanics, except that the model for electricity and the model for light coming out of the collision, we can call it collision, is different. Their notion of what current is a bunch of little particles coming out of the metal, polished metal. Ours is that the particles are still there, the atoms are still there, they're just merged and spinning. That's what's happening. And light obviously loses frequency because it hits something. Okay, the incoming light has higher frequency than the outgoing light. And in the case of the rope model, all we have is longer wavelength of longer link length, really, of the rope. That's it. So these are the two models. These are the two mechanisms for you to ponder. Okay. And again, the problem with the atom that the quantum mechanics has there is we don't know why those little red balls known as electrons don't fly out spontaneously from the atom. Okay, and I think we have one more question here, or comment. I like this one. We'll end the day with this. Fella says, he says, I'm sad that Bill no longer replies to comments. Those were the good old days. I do reply to comments. I don't reply to comments directly on YouTube, partly because a lot of people erase. They come in, they do a hit and run. So they put comments, you answer it, and then they vanish and they leave you talking to the wall. That's happened to me so many times, and it's one of the reasons I stopped answering comments. And then I do answer comments here. So all you got to do is watch the next video and you'll probably see your comment being addressed here. Okay. And so we'll see you on Wednesday, and I'm going to be here with Ans, and we're going to do our monthly review of the previous month. Okay. So if you have any questions, comments, we're going to address them real time on Wednesday. We'll see you there.